Thanks for coming. Thanks to everyone for joining. Thanks for your patience. But I hope it will be worth it, this presentation, and gonna save you time in the future. Well, the presentation of today, it's Power BI, Merge Challenges and Solutions. I'm data analytics engineer at Lego Group for a bit more than a week, and this presentation is for the new starts of data. Fun facts about me, or just facts, let's say. I'm 31 years old. I live in Odense in Denmark for 4 years now, living in Spain for 20 years between Madrid and Logroño in La Rioja. My background is in economics, but I've been working as data analyst for companies here in Denmark, like Southern Denmark University, Universal Robots, and my previous company, D365 Advisors. My hobbies, of course, it's building up Legos, and the bigger the sets, the better. And another hobby is that I'm a data enthusiast, I would say. So I'm really into the last trends of data analysis, automation, and digitalization. And this is one of the main reasons I'm doing this presentation today, because I would like to know more about data analysis, how to do the data cleaning, and share my takeaways from my professional experience. So you guys don't have to spend hours and hours trying to troubleshoot some of the errors I faced. Today's point gonna be the first one. Gonna be really fast and a short presentation about the data set, and then the reality-based problems I faced in my previous experience. These problems, I would say, are really frequent, or I would say more frequent than we expect, like inconsistent naming, duplicate records, handling different granularity of the data type mismatches, and missing data. And for the three first points, I'm gonna make a live demo, which is a couple of steps in the queries and to see the results in the back end on Power Query for Power BI. The data set. The data set is Northwind. I'm not sure if you guys are familiar with it, but it's an ERP data set for testing and learning purposes created by Microsoft. You guys have the link to access it as an API, and you guys can play around to see what steps or what techniques in your data analysis, data cleaning, data manipulation, visualization you would like to have. And I think it's a really good data set that captures the reality out there, I would say. The categories, the tables I selected from this ERP model, it's categories, orders, order details, products, and categories. Categories, products, order, and order details, and order original. The data structure, it's a snowflake that from a main table, it goes towards different tables in more details or adding new aspects to the main table. The first problem I'm gonna show is the inconsistent naming. As point of reference, for the table categories, we have columns which apparently are the same. They have the same column header, category ID, category name, and description. And secondly, it is when we try to append these two tables, we get a new table which has 3 columns. Instead of 3 columns, it has 5 columns. So it's pretty scary, because when we looked previously to it, it had only 3 columns. So what could have been going wrong in here? And it is that we didn't pay much attention when we appended the 2 different tables. And the thing it is that the category ID was category underscore ID in one table and category ID in the other table. And the same for category name, that one table had category name and the second table had category names. So there are these small details can drive you to really unexpected results, like from having a table with 3 columns to have a column with 5 columns. And here I'm gonna show you the live demo about it to see how it looks and how we can troubleshoot it. If you guys allow me. I hope there is no background sound of the fan of the computer.
No, you're all good. You're doing fine.
Here we have the tables. If it gets loaded. So here we have the first table, category ID, category name, and description. And secondly, we have category ID, category name, and description. And then when we want to append the columns, oh, sorry, there is somebody who is unmuted. Yeah, thanks.
I'll deal with that.
Yeah, thanks. So now if we go here, we want to append these two tables. Let's do it. Append queries. We try to append the new table. Of course, we had some issues. Sorry, it was the other one. Append queries. Boom. Here you see guys, now from 3 columns we got to 5 columns. It's not a big deal when the data set is this small, but when we're working with large data sets, sometimes it's not really easy to see these small details of the naming of the columns. And when you try to plot or draw some dashboards, it's really misleading and confusing. So one of the possible troubleshoot for this, it is to make a partition of the tables we're working with, because when we work with ERP datasets, sometimes we have 150 or 200 columns. So the best thing it is to just stick to 5 columns or 10 columns when we do this sort of append, because in this way it's easy to catch the difference in the naming of the columns. So this is the first trouble and the first troubleshoot of the inconsistent naming. Then we have the duplicates records, which is another big problem that I faced in my previous jobs. And it is that when we're working with different tables and we try to answer different questions from our boss, our manager, or different stakeholders, we don't pay much attention to what tables we merge to what tables to have the whole picture. For example, for the sales by country or by region or postcode. So it's a really, really common problem that I faced, and I face it frequently, no matter what data set it is. Most of the times I have to deal with this problem. So I hopefully that by explaining a possible troubleshoot for this, it's gonna save you time in the future. For this problem, our point of reference is that our ERP dataset, the sum of quantities sold is 51,000, the count of orders is around 2,000, and count of distinct orders is 830. So distinct orders, it's different from count of orders that they have a unique ID. So in here, we are applying some left joins between the table categories and products by the column category ID without paying much attention. And few moments later, we increased the sales by more than 20,000 units. The count of orders jumped from 2,000 to 10,000. So definitely something went wrong, that you refresh your data set and all of a sudden you have these massive numbers. You don't understand what happened. Is like most likely you got a duplication error. A possible troubleshoot for this, it is to make a quality check on the merged tables by grouping by. So in this example, we see that for the category ID, we have two double entries for the category group 1, 2, and 3. So on the top right corner, we can see that this category ID, it's doubled for these three category IDs 1, 2, and 3. So when we apply the left join for the sales, we apply the total number of sales twice for this category ID 1, 2, and 3. So this creates a duplicate, and another additional error of having repeated values for the index column you merge the columns between is that when you have one-to-many relationship, when you refresh it, it doesn't recognize. It gives you an error and it says we cannot process this because we cannot process one-to-many connections with repeated values for the category ID. So guys, anytime when you merge different columns, I really recommend to work with unique identifiers or unique IDs for the index column. In this case, it's category ID, and to double check that you are working with unique identifiers. It's an easy way to do it. It's grouping by. So when you see that the count rows it's above 1, then that's not a good index for you for merging the table. So try to find another way to put together the different tables. And for that, I have the demo live. Hopefully it's gonna be easily understandable or easy to get. So here we have the tables we want to merge by left join, and here we have the table category. And if you have like a really swift eye or really agile eye, or let's put it in that way, you already could see that 1, 2, and 3 it's already repeated. But when you have 1,000 or 10 of 1,000 of rows, it's not like an easy job to identify those duplicates. So most of the time is what somebody would do is like, yeah, I'm gonna merge these two tables. So now I have the sales for the different category IDs and the different products that are attached to that category ID. So we would go merge query, And for the merge query, we go category ID by category ID. We applied a left join, one to many. We expanded the columns we want to see, the product name, the supplier, the quantity, unit price, all these things. And then when you refresh and apply, it is like, okay, the number of sales, it increased by 50,000. The orders the company had just by one refresh, it increased by 10,000. So it's like really scary, especially if you have a meeting with the stakeholders, with the managers, and you present this sort of data. They are like, are you sure about that, buddy? Are you sure that in one day we had 10,000 of orders? So this thing, to double check by group by, it really helps and makes your life much easier, I would say. So in here, you only have to do group by, category ID, count the rows, and advanced category ID, and we add the columns, category name, and the description. And here, bang, the duplicates we have. And now this table is good to go for the merging. So you have to merge the tables that have a unique identifier. So in this way you make sure that you will not have any duplicates added to your report. The third problem is the different granularity. By different granularity, I refer what is the dimensionality of the data set. For example, the higher the dimensionality, the higher the details we have for each of the product. Let's say that we have more detailed information, so it's more granular. Most likely all of you guys are pretty familiar with this. With these terms, I'm not gonna deep dive more into the definition of granularity. In here, as point of reference, I took the sum of quantity, which is 50,000 for the sales, and I grouped them by country, so we can see the different sales for the different countries. And yeah, for the different granularity, I'm using the table order details, and we are applying some group by for the ship country and the quantity. And secondly, we apply for the table orders a group by for the columns order ID, ship city, ship country, and quantity. And lastly, we merge by left join by the orders to order details and by the country. What happens 3 hours later? We do all this data manipulation. We try to see the relationship between the different columns, and we say that, yeah, this is what I want. I want to have the orders national level applied to the sales by the region and the country. And I know this might sound like, yeah, that sounds legit, that sounds normal. This is something we want to know. This is something that makes sense, but actually it doesn't make sense, and it happens more than we think, because when we're working with data analysis or data manipulation or processing of the data, we always sort the data in a way that we answer to questions. And sometimes it happens that we are pumped by different questions that we we sort the data in so many different ways that we can track of the nature of the data that we are working with. So what happens then is that, of course, we increase the sum of quantities to almost 500,000. We increase the sales by 300,000 units. So definitely something went wrong, because if we see the results after applying the data processing in comparison to our point of reference, we have 50,000, and now we have almost 500,000 of sales. So something definitely it went wrong. And believe me, you guys wouldn't like to be in front of the main stakeholders of your company and show these numbers. Guaranteed. So what happened, or how can we solve this problem? So for me, the mental roadmap I have when I work with dataset, it is that always I go from the more granular data to less granular data, and not the other way around. Because in the previous slide, what I showed is that we are going from less granular data set to more granular. We applied the aggregated numbers to the not aggregated numbers. So that's why we increased the sales by 300,000. So the way to go, it is to always align the dimensionality between the different tables, that if we want to compare the sales by the region, then we work only to the regional level. If we want to compare the sales by country, we only work country-wide. If we want to compare by group ID, for example, plastics, metals, and polymers, for example, then you only work on that level. You don't get into more details within the plastics or metallics or polymers. And to make sure that we go, I make a lot of emphasis into this, that we're going from the most granular table to the most aggregated table. And I don't know your background, guys, but if you guys work with ERP system, it's most of the times, or 99% of the times, you guys work with order ID or product ID or BOM, which is the bill of material. And you go from that point, which is the most granular part, to the most aggregated part. So the starting point, it is the most granular data you can have, built from that point onwards, and not the other way around, from the aggregated part to the granular part. And sometimes it happened that the company works with different systems, and there is not a homogeneity between the different data sets or data tables. A possible way to go, it is to create a unique identifier or a unique index. And for that is just merging the two columns by a separator, like a column or semicolon or underscore or a dash. So we would have order ID / Caracas / Venezuela. So that for you would be the most granular part to have. So this is a way to have a point of reference while going to different tables to left join. And for this also, I have a demo to see how I get these duplicate values by not managing well the different granularities of the tables. So, okay. So yeah, here we have the orders, and from this part, it was really granular. We have the different variables for it, the different columns for the shipping address, shipping region. So it is pretty granular, let's say. What I did, it's the rows, the columns, I grouped it by its order ID, ship city, ship country. And for all of those, I can see that I have a unique value. I removed that, and then I went to duplicate orders, and here is where I have as well the really granular data, and here for the different data I merge to the previous table group by. I have the national one, and here I apply it again. So here is where I created the duplicate values for the quantity. So I count the quantities thrice, I would say. So what I've been doing in here, it is that I have the sales here aggregated by the different countries, and here I have for the cities within the countries, and I applied the national sales for each time the city of a country is repeated. An example, let's put it in this way. So for Argentina, we had different orders. We had 16 orders. So I applied the national quantities of Argentina 16 times. Then for, let's say, Austria, even more, we have like 50 entries for Austria. And then I applied the sales of Austria 5,050 times. So guys, be really careful about this. Always it's good to have the same level of granularity between the different tables, so you don't put the national sales 50 times for each of the different orders you guys had in the same city. This is how I displayed the numbers. This number of the quantities, which jumped from 50,000 to almost 500,000. The fourth problem that I faced, it is the data mismatches. What does it mean? That when we try to merge two tables by a column, it happens that the order ID it could be a number, a whole number, and on the other table it's a text. So when we try to merge these two tables by index column, in this case order ID, we cannot apply the merge, and and we have a warning that okay, the select types cannot be matched. This is I would say it's like easy to solve, but it's not that easy when you are working with 150 or 300 columns and different tables at once. So always be aware that it's possible to, of course, to change the data type of the column of index, but also it is possible that when we add a new data source to PowerCure, we have the determined change type step. This change type step, it can be changed on the settings and modified for the nature of your work. I still work with the change type, so it does apply determined change type to the different columns, but also it's possible to skip this part. So what I'm trying to say is that by doing this, you guys have a pros and also a cons. That sometimes it's annoying that you have to go to the column 299 to change the type of a column you want to merge. So it's important to have always in mind the naming of the columns you are using as index, but also the data type. That when you merge a column, you're not spending time scrolling the screen to go to the column 299 and then coming back to the second column and to go to the column 150 to apply the merge. So it's important to have this thing on mind, and also to have on mind that it's possible from Power Query to change the settings if you feel more comfortable by doing this, or you prefer Power Query not to apply determined change type to your column headers. And on top of that, it is another way that I like to work is that when I have extra large data sets, to work with partition of the data. So I have this whole table with 300 columns, and okay, I'm not gonna work with all of these columns. So I focus only on 5 to 10, okay, maximum 15 columns, and all the other 285 columns I'm not using, or 290 columns I'm not using, to drop them off. So for me, it's clear to see what's going on, what columns I'm working with, and what's the nature of the different columns I'm working with. And then always you can come back to those 280 columns if you want additional information to have it in the report. This is, I would say, it's easy problem to solve, but still sometimes it generates a lot of trouble, a lot of time consuming if you're working with large data sets. And the fifth problem is the missing data. And I'm using as point of reference the count of the orders and orders that are null within the orders. So the way I have the point of reference, it's okay, I have null values and not null values. I apply dummy variables, which are one if there is no null values in the table, and the contrary, 0 if there are null values. And for that, I have 2000 order ID and 830 distinct order ID. The missing data, a possible troubleshoot to handle the missing data, it is that we can apply synthetic data. For example, what does it mean, synthetic data? That we work with averages, that we fill up the null values with the average for the order ID or the product ID or some sort of grouping variable for the different products. But it happens to me that sometimes these things doesn't make any sense, that I present the dashboard or KPI to the stakeholders like, but this makes no sense. So every company is different from each other, and every company has a different view of the reality. So do not apply any synthetic data if you don't have any feedback from your main stakeholders in doing so. So the way I've been working with this is that I partition the data. In one, I have the data with the non-null values, and the other one I have only with the null values. And then when I apply the KPIs to see what's the difference between the two tables I have, what's the difference by including or excluding the null. So this AB, it's really useful. And of course, by doing this, also you can, by having a table with null values, you always can escalate to your stakeholders. What does this mean, escalate the problem? So you go to your manager, to your boss, or the head of the department that is in control of this data, and ask, look guys, I have this order IDs number. I cannot find the quantity in the table. Why is this so? Is because the data was not correctly put, is because it's a back order. So the person in charge of the data is gonna tell you more information about how to handle this order ID. And sometimes it can be because it's a supply chain problem, that the order ID is created, but the product was not delivered yet. So there is no idea of the quantities that is being delivered, because in the supply chain sometimes there is errors that the quantity is 10 but then provide you 5 or 15 or 20, because maybe from the same supplier there is multiple orders and they put all the orders together, or a big order they split it in different orders. So this is a really common problem, and always try to not eliminate the nulls. This is a big no-no. Never eliminates the order ID with null values, but adding the test A and B, and to escalate to the responsible, escalated to to your boss, to your manager, to the main stakeholders. And all in all, these were my 5 points that I wanted to present today, the most common problems I had to face. And now I jump for the section of questions and answers.